let us now discuss about the concept of interference of light. After that we have diffraction, then polarization. This is the order we have to take up. What is interference of light? Interference in general sense, it is nothing other than overlapping. But what is overlapping here? The light waves are overlapping. Then what happens? There will be variation in the intensity of light in the resultant wave thereby formed. That intensity at few places will be maximum, at few other places will be minimum. That's what actually we people are going to observe in the case of interference pattern. But what is interference from physics point of view? The modification in the distribution of light energy due to the superposition of two or more waves, that is called interference. The modification in the distribution of light energy due to the superposition of two or more waves, that is what we call it as interference of light. This interference, whenever we observe, alternate bright and dark bands we are going to find there. And in fact, we all can understand that bright bands are due to constructive interference and dark bands are due to destructive interference. That also we can understand. But what is happening to that light in the dark band? It's totally becoming dark means light is not reaching there at all. It's not the concept. Light is reaching, but the intensity is getting cancelled by one another. The intensity effective value is becoming 0 there. Effective value of intensity is becoming 0. That is why we people are getting directly a dark band over there. Fine. But what is happening to that light? That light is added to the other part of it, that is brightness. So bright band will be too bright, and a dark patch, whatever we are finding dark fringe like, that is too dark. And this is just because of the law of conservation of energy. In this particular case, light energy is being conserved. That is what we have to understand as the basic concept of interference of light. So let us go in a detailed manner. What is interference of light and what are the conditions needed for us to get bright band at a particular point on the screen or dark band at the same point on the screen? And what is the formula for fringe width? That is the thickness of the fringe that is formed, whether bright or dark. And what are the conditions for sustained interference we are going to have? All these cases, one after the other, let us discuss now. So we are just taking up the concept of interference of light. First and foremost, for obtaining perfect interference, we require to have coherent sources. What is coherence here? Coherent sources are those sources of light which will emit light with the same frequency. Right? Either with the same phase, or with a constant phase difference, That is the pair of sources which we call that pair as coherent sources. The sources of light which can give out light of same wavelength, same frequency, either with same phase or with a constant phase difference. Now, how to get this pair of sources like? How to get coherent sources? For that, you can have a cardboard on which two identical slits when you just make. Both are supposed to be identical by nature. When you place a source of light nearby, whatever the light that is coming out of these two sources or these two holes or slits, what we call them, that light is called as coherent light. Or that pair of slits, we can call them as coherent sources of light. Now, in this regard, coherent sources, whatever we are talking about, both may be real. So, both the sources may be realistic ones. You can see them there. The second option is both even may be virtual also. In the case of Fresnel's biprism, there is one prism by name Fresnel's biprism. Whenever we use Fresnel's biprism there, both the sources whatever we are going to observe, which of course are giving us interference pattern, that pair of sources, they are virtual sources by nature. That means both the sources may be real sources, both the sources may be even virtual also. Fine. There is one more option. One may be real and the other may be virtual. Out of the two sources, one source may be real, one source may be virtual. Where we come across such type of a situation? There is one instrument by name Lloyd's mirror. That Lloyd's mirror, whenever we use to obtain interference pattern, one source will be a realistic one. Its image over there formed itself behaves as if it is another source, which of course is making a pair of coherent sources. So, one source will be real there and one source will be virtual there. So, whenever we come across coherent sources, there is no rule that both the sources must be real only, like they both may be real, they both may be virtual. One may be real and one may be virtual also. But the conditions are supposed to be satisfied. What are the conditions over here now? They should send the waves of same wavelength with same frequency. Fine. In addition to that, either with the same phase, there should not be any phase difference between them at all. That is excellent. Or else with a constant phase difference. Whatever the phase difference initially we are observing between them, the same should be continued till the end. That means constant phase difference. The phase difference is to be maintained constantly in that case. So, this is actually, these are the conditions for obtaining a coherent sources of light. And one need to have a pair of coherent sources for observing sustained and perfect interference pattern, in which we people are finding directly alternate bright and dark bands as such. Now, what is the principle behind that? And what are the conditions for bright bands or dark bands which are being obtained at a point on the screen like? Let us now discuss in a detailed way.